I am Chandrakant K. Bhange, Assistant Professor of AI CSMS IOIT, E&TC Department. Media Access Control. I made this video for E&TC student. Let's start with the media access control. So, what is media access control? When nodes or stations are connected and use a common link called a multipoint or a broadcast link. We need a multiple access protocols to coordinate access to the link. The problem of controlling the access to the medium is similar to the rules of the speaking in the assembly. The procedure guarantees that the right to speak is upheld and ensure that two peoples do not speak at the same time, do not interrupt each other, do not monopolize the discussions, and so on. So many protocols have been devised to handle access to the shared link. All of these protocols belongs to the sublayer in the data link layer called a media access control. Media access controls protocols are divided into the random access protocols, control access protocols, and channelization protocols. Random access protocols again divided into the Aloha protocols, carrier sense multiple access collision division protocols, carrier sense multiple access collision avoidance protocols. Controlled access protocols again divided into the reservation protocol, pooling protocol, token passing protocol. Channelization protocols are again divided into the FDMA, TDMA, and CDMA. So what is Aloha? Aloha is the basic protocols. Aloha, the earliest random access method, was developed at the University of Hawaii in early 1970. It was designed for the radio LAN, but it can be used on any shared medium. It is obvious that there are the potential collisions in this arrangement. The medium is shared between the stations. When a station sends data, another stations may attempt to do so at the same time. The data from the two stations collides and become garbled. So Aloha protocols is divided into the pure Aloha protocols and slotted Aloha protocols. Pure Aloha protocol, the original Aloha protocol is called a pure Aloha protocol. This is a simple but elegant protocol. The idea is that each station sends a frame whenever it has a frame to send multiple access. However, since there is only one channel to share, there is a possibility of the collision between the frames from different stations. See in the diagram, there are 4 stations that contends with the one another for access to the shared channel. The figure shows that each station sends 2 frames. There are a total of 8 frames on the shared medium. Some of these frames collide because of the multiple frames are in the contentions for the shared channel. See in the diagram shows only 2 frames survive, 1 frame from the station 1 and 1 frame from the station 3. Okay, next type is the slotted Aloha. In slotted Aloha, we divide the time into the slots of TFR second and forces the station to send only at the beginning of the time slots. See in the diagram shows the example of the frame collision in the slotted Aloha. So because a station is allowed to send only at the beginning of the synchronized time slot, if a station miss this movement, it must wait until the beginning of the next time slot. This means that the station which started at the beginning of this slot has already finished sending its frame. Of course, there is still the possibility of collision if two stations try to send at the beginning of the same time slot. So the vulnerable time is now reduced to 1/2 equal to TFR. Next is the CSMA. CSMA is the carrier sense multiple access. To minimize the chance of the collisions and therefore increase the performance, the CSMA method was developed. The chance of the collisions can be reduced if the stations senses the medium before trying to use it. Carrier sense multiple access requires that each station first listens to the medium before sending its frame. In other words, CSMA is based on the principle of sense before transmit or listen before talk. CSMA can reduce the possibility of the collision, but it cannot eliminate it. The reason is that the space and time model of the CSMA network stations are connected to the shared channel. The possibility of the collision still exists because of the propagation delay. When a station sends a frame, it still takes the time for the first bit to reach every station and for every station to sense it. In other words, a station may sense the medium and find its earlier ideal only because the first bit sent and another station has not yet been received. Next type is the collision detection methods. A station monitors the medium after it sends a frame to see if the transmission was successful. If so, the station is finished. If, however, there is a collision, the frame is sent again. The carrier sense multiple access method was not specified the procedure following a collision. Carrier sense multiple access with the collision detections augment the algorithm to handle the collisions. See in the diagram, station A and C are involved in the collisions. At the time T1, station A has executed its persistent procedure and starts sending the bits of its frame. At time T2, station C has not yet sensed the first bit sent by A. Station C executes its persistent procedure and start sending the bits in its frame, which propagates both to the left to the right. The collision occurs sometimes after the time T2. Station C detects a collision at time T3. When it receives the first bits of A's frame, station C immediately aborts the transmission. Station A detects the collisions at time T4. When it receives the first bits of the C's frame, it also immediately aborts the transmission. So look at the diagram. We see that the A transmit for the duration T4 minus T1, C transmit the duration T3 minus T2. Carrier sense multiple access collision avoidance was invented for the wireless networks. So collisions are avoided through the use of the CSMA/CA. So it uses the three strategies: the interframe space, the contention window, and acknowledgement. Next type of the protocol of control access is the reservation protocol. In the reservation method, a station needs to make a reservation before sending the data. Time is divided into the interval. In each interval, a reservation frame precedes the data frame sent in the interval. If there are the n stations in the system, there are exactly n reservation minimum in the reservation frame. Each minimum belongs to a station. When a station needs to send a data frame, it makes the reservations in its own mini slots. The station that have the made reservations can send their data frame after the reservation frame. Next type of the protocol is the polling protocol. Polling works with the topology in which one device is designed as a primary station and another device are the secondary stations. All data exchanges must be made through the primary device even when the ultimate destination is the secondary device. The primary device controls the link, the secondary device follows its instructions. It is up to the primary device to determine which device is allowed to use the channel at the given time. The primary device therefore is always the initiators of the sessions. This method use the poll and select the functions to preserve the collision, to prevent the collisions. However, the drawback of is if the primary station fails, the system goes down. Next is the token passing. In token passing method, the station in a network are organized in a logical ring. In other words, for each station there is a predecessors and the successors. The predecessors is the station which is the logically before the stations in the ring. The successors is the station which is after the stations in the ring. The current stations is the one that is the accessing the channels. Now the ring to this access has been passed from the predecessors to the current stations. The right will be passed to the successors when the current stations has no more data to send. But now is the right to access the channel passes from one station to the another. In this methods, a special package called a token circulates through the ring. The possessions of the token, the positions of the token given the station the right to access the channel and send its data. When station has some data to send, it waits until it receives the token from the predecessors. It then holds the token and send its data. When the station has the no more data to send, it releases the token, passing it to the next logical stations in the ring. The stations cannot send the data until it receives the token again in the next round. In this process, when a station receives the token and has no data to send, it just passes the data to the next stations. Token management is needed for this access method. The station must be limited in the time they can have the possessions of the tokens. The token must be monitored to ensure it has not been lost or destroyed. For example, if the station that has holding the token fails, the token will disappear from the network. Another functions of the token management is assign the priorities to the stations and to the type of the data being transmitted. And finally, token management is needed to make the low priority stations release the token to high priority stations. So be aware of the three persistence methods. First one is the high persistent method, second one is the non-persistent method, and third one is the p-persistent methods. These methods are used in the reservations. So see the logical ring and physical topology in the token passing access. So first one is the physical ring, second one is the dual ring, third one is the bus ring, and fourth one is the star ring. These four rings are used. This is the logical ring. In token passing network, station to be physically connected in a ring. The ring can be a logical. See in the diagram shows the four different physical topologies that can create the logical ring. Next one is the channelizations. Channelization is a multiple access method in which the available bandwidth of the link is shared in the time, frequency, or through the code among the different stations. In this sections, we discuss the three channelizations protocol: FDMA, TDMA, and CDMA. Thank you.